Kia ora e te whānau, nau mai, haere mai, and welcome to Daily Demos. Today we are doing science, so I have Kind Koala with me, and I have Frankie. But before we start to talk about our scientific method, let's start with a karakia. Mahunga ki raro, heads down. Kia inoi tātou, manawa mai te mauri nuku, manawa mai te mauri rangi. Ko te mauri KO, he mauri tipua, ka pākaru mai te pō, tau mai te mauri, haumi e, hui e, tāiki e. Ka pai, alright, now that cheeky bee is somewhere in the room hiding from me again, but it's extra tricky to spot today. Can you find it? Try and find it during the lesson. Okay, now we're going to be amazing scientists for this lesson. So you are going to be a little scientist. I am. Kind Koala is going to be a little scientist. And Frankie's going to be a little scientist. Right, Frankie? Okay. So when we are scientists, we do something called the scientific method. Now that's a list of things that you need to do to have a really successful experiment. And because we're experimenting today, we need to learn about the scientific method. So there are a lot of steps. I will read them to you in little parts. The first part is we need to think of a question. So for our experiment today, I have a very special robot. Now, because we're looking at balancing robots, I'd like you to have a little look at what happens when I try to balance this robot on my finger. He's balancing. He's doing a handstand on my finger. How do you think I'm doing this with my robot? How did I make this robot balance? This is really curious. I think I have a bit of a question coming on. A question about why this robot balances. What could our question be? Our question is going to be, how does balancing work? Now, next are two important steps, but we're going to start with the green one. Materials. Materials is what you need for your experiment. So you at home, make sure that you have these things all ready for your experiment. So the first thing we need is paper and cardboard. So I've got some paper and I've got some sort of card or cardboard that I'm going to stick my paper to make it a little bit stronger. You could use the back of a muesli box or a Weet-Bix box or a tea box or anything that you like. It just needs to be A5 sized, which is half of a normal piece of paper. Okay, the next thing you need is scissors. After that, make sure that you have glue. Now you don't need glue if you are really lucky and you happen to have some card at home. Card is the thick paper. Okay, but unless you have card, you definitely need some glue. You also need 2 coins that are the same type. So I've got 2 $1 coins. You might have 2 20-cent coins, or you might have 2 $2 coins, whatever you choose. Okay, and the next thing you need is blue tack. If you don't have blue tack, you can use sellotape. And finally, we need, can you help me, Kind Koala? We need some pens or pencils, whatever you like to colour in with. And here's an optional part. Now, I really do recommend it. Down the bottom, underneath this video, there should be some words that say balancing robot printout. Now that's something you can print out that looks like this, and it has the robots already drawn for you so that the experiment will definitely work. Now if you don't have a printer at home, that's fine. You could always get a piece of paper, put it on your computer screen and trace around the robot, draw on top of the paper. Or what you could do is have a look at the screen and try and draw your own robot, which is absolutely fine. Just make sure that your robot looks kind of like the one on the screen and it's the same on both sides. It doesn't have one big long arm and one little arm, or it doesn't have one really fat leg and one little leg. It needs to be the same on both sides. So you might need an adult to help you with that. Okay, so the next step is procedure. Procedure. So procedure means the steps you're going to take. So our first step is coming right up. So here is how we start our experiment. The first thing I'd like you to do is to get your balancing robot printout or the drawing that you made and simply to colour it in. Ready, Kankoala? Now you'll see that your balancing robot sheet or the tracing or drawing that you did, there will be two robots. You don't have to do both of them. You can just do one unless you'd like to have a face of the robot on the front and on the back. Then you can do two. Okay, now I have my robot all ready to go, so what I'm going to do is glue it onto my cardboard to make it a bit stronger. Okay, my robot is all stuck onto my cardboard and I'm going to cut it out. Alright, now that our robot is all ready to go, we are going to make a hypothesis. A hypothesis. Hypothesis means a prediction, and a prediction means my guess. What do I think will happen? So I've got 2 coins. I've got 2 coins and some blue tack. I'm going to stick some blue tack on the back of my coins, nice big bit. And your goal is to try and make the robot balance on your finger. How are you going to stick on your coins so that your robot balances? What's your prediction? What's your guess? Where do you think that the coins will need to stick to make your robot balance? Have a think, talk to the person around you, talk to someone at home. Do you think that the robot will balance on your finger if you put 1 coin here and 1 coin here? Do you think it will balance if you put them both on the head? You make a prediction what you guess is going to happen and we'll see if your guess is right. Okay, now's the part when you get to play around. I'm going to play around too. So I'm going to try putting my coins on the back of my robot in different places and try and make it balance on my finger. You do the same. I'll put one on the top foot and one on the bottom hand. Okay, didn't work. Nope. Have you been trying? Have you found how to balance the robot on your finger yet? I haven't. Okay, I've tried 1 here and 1 there. I've tried 2 on the head. I've tried 2 on this arm, 2 on this arm, 2 on that foot, 2 on that foot, 2 on the body. It's just not working. Okay, now I'll try one final thing. You might have already tried this. I'm going to try putting my 2 coins on the bottom hands of my robot. Let's see if it balances. It balances. Does your one balance if you put your pennies, your coins, on the two bottom hands of your robot? Let's try lots of different places that we can balance our robot. I found lots of different places I could balance my robot. But now that we've done our question, so how does balancing work, have we answered it yet? No, because we're not finished with our scientific method. We made a guess. We guessed what we thought would happen. We got all of our materials, the things we needed. We took some steps to do our experiment. And we have our results. Results is the next step. Results means what happened. So what happened? Where did the pennies or the coins need to go for the robot to balance? That's right, they had to go on each hand, so on both sides of the robot at the bottom. So those are our results. Well, there's only one part left. Conclusion. What did we find out? Well, firstly, was your prediction correct? Was your guess right? Did you guess that the robot would need to have a coin on both bottom hands? Or did you guess something else? It's actually the most fun when you guess something else and you prove yourself wrong, because you get to learn something really interesting. But we're not done with our conclusion, because we need to find out the answer to our question. How does balancing work? Let's take a look. Okay, so what is gravity? Well, have you ever tried standing on a ball before? Right, you can stand on it for a while, but then you eventually fall off. Now, the reason you fall off is because of gravity. Gravity pulls you back down to the ground. So if I have this pen, if I drop it, it falls straight down as close to the ground as it can get. But seeing as if we stand on a ball, we fall off, and we're living on Earth, which is a ball, why don't we fall off Earth? Well, that's because of gravity. Because gravity is always pulling us back to Earth, back to the ground on Earth. That's why when you have a spaceman in outer space, if he let go of a pen, it would float. Or if he stepped off the moon, he would float around because there's no gravity there. So that has a lot to do with our balancing robot. Well, of course, if I drop my robot, it will fall to the ground. But I mean, why does it balance? It's all to do with gravity. It's called the center of gravity. Can you repeat that after me? Kōrero mai? The center of gravity. The center of gravity with my robot is where my finger is going. The center of gravity is the place where the weight is the same on all sides. So if I put 2 coins on one side, it's going to be more heavy on one side and it's going to fall. If I put 1 coin on this side and 1 coin on this side, I'm making the center of gravity my finger because it is just as heavy on this side as it is on this side. So how about some other objects? If I have a ruler, the ruler is a nice even shape. So if I want to find the center of gravity, find the place where I can put my finger to make it balance, it might take a while, but it should be right in the middle, like that. So if I have an apple, which is around about the same on both sides, I should be able to find the center of gravity right in the middle if I put my finger there. Let's try. Ooh. For a little while anyway, and then it tips because I'm moving. What's one more object we could try? Well, how about Emmy? If I put my hand in the middle of Emmy, she's the same on both sides. She's just as heavy on this side as she is on this side. Then I should be able to balance her by sitting her in the middle. Great. But if I put my hand here, it's a lot lighter in her head than it is in her bottom. So what will happen if I put my hand here? She just falls straight off. So the center of gravity is the place where the weight, the heaviness is the same on both sides, which is why if I put my coins both on the same side as the robot, then that weight's gonna pull it down. But if I have my coins on two different sides in the exact same place so that it's just as heavy on this arm as this arm, then it balances. But then how come I can't do it if I put the coins at the top on the feet? Because it's just as heavy on this foot as it is on this foot, but it still falls off. Well, that's because my center of gravity has moved. The weight is all the way at the top, so I need to make sure the weight is pulling down to the ground, because the weight is always going to want to go to the ground because of gravity. So maybe it would work if I had my legs at the bottom and I put my pinky finger in the middle. Oh, it balances. Yeah, it does. Because my center of gravity just here in the middle has the same weight on both sides. So I hope you learned a lot today about gravity, the center of gravity, and how that affects balancing. And I hope you had a lot of fun making your balancing robot. Okay, I think it's time for us to do our karakia to end our lesson. Mahunga ki raro. Ia inoi tātou. Ka pā ki tua, ka pā ki waho, ka pā ki te whare, ka pā ki te roa, ka pā ki te pau e tūnei, kia mā te ariki, kia mā te tauira, nō hau e rua tau, e tāne te wairoa e. Whānau, whāna, haramai te toki, haumi e, hui e, tai ki e. Ka pai tō mahi, great work. Well, I had tons of fun today with Kain Koala and Frankie and our robot. So I hope you enjoyed it, and I will see you tomorrow for the next daily demo. Ka kite!